This is section 11.2, Arithmetic Sequences. We introduced the idea of a sequence in 11-1. Today we're going to delve deeper into the idea of an arithmetic sequence. How do we find the formula for the nth term of an arithmetic sequence? How do we find specific terms of an arithmetic sequence? So those are going to be our two tasks today. These are not that difficult, I don't think. You just have to kind of understand the idea behind them, and then things should come fairly naturally. It's just a matter of adding and multiplying. No variables, no weird algebra type stuff. So, here's a question. How do we find the 100th term? If our sequence is 2, 5, 8, 11, and 14, how do we find the 100th term? Now, you might have noticed that we have a difference of +3 from one term to the next. So we have an arithmetic sequence. You can see that 11 is T4, the fourth term, and there have been 3 differences of 3 applied from term 1 to term 4. 1, 2, 3. T5 is 14, which is after the fourth difference of 3 from T1. 1, 2, 3, 4. So, how many differences of 3 will there be for the 100th term? 99 differences. From term 1 to term 2, there's 1. Term 1 to term 3, there's 2 differences. From term 1 to 100, there will be 99 differences of 3. So to find T100, we have to apply 99 differences to the first term. Our formula would be the first term, 2, plus 99 times the difference of 3. And that yields us a total of 299. So our 100th term is 299 because the number of differences from the first term is the term number minus 1. For Tn, we would apply the difference n minus 1 times and add it to the first term. That's what we did with T100. We added it 99 times the difference, which leads us to our general formula for an arithmetic sequence. If an arithmetic sequence with the first term T1 and common difference d, the nth or general term is given by this formula. Tn equals T1 plus the quantity n minus 1 times d. So this was derived just the same way we figured out that 100th term. The nth term is equal to the first term plus the number of differences of the term minus 1 times the difference. This is something you're going to want to memorize for these chapter 11 problems. Let's take a look at example 1. Find the formula for the nth term of the arithmetic sequence, 7, 11, 15, 19, and so on. So we're going to use the formula, just plug things in. First of all, we need to figure out what the difference is. You can see quickly that the difference is 4. Next question, what's the first term? Well, that's easy, that's 7. So now it's just a matter of plugging things into the formula. Tn equals T1 plus n minus 1 times d. We know what T1 is, it's 7. We know what d is, it's 4. So now at this point, all you do is expand and simplify the expression. 7 plus 4n minus 4 after you distribute the 4, combine like terms, and Tn, the nth term of this sequence, is equal to 3 plus 4n. So look at the difference, look at the first term, plug them into the formula, simplify. Try number 2 on your own. We have another arithmetic sequence. See if you can find the formula for the nth term. So our difference is 1, a positive 1. And our first term is negative 1. So you take those values, you plug it into our general formula. T1 is negative 1, d is 1. Again, combine and simplify. Negative 1 plus n minus 1. So the nth term is simply n minus 2. And which makes sense. If you check this, this is the third term. 3 minus 2 is 1. 3 is the fifth term. 5 minus 2 is 3. So the formula checks out with the sequence, and that's a good way just to make sure that you've gotten the sequence right. Example 3. Find the specified term of the arithmetic sequence. 2, 5, 8, and so on. We want to know T17, the 17th term. So, first of all, let's again figure out what the common difference is. In this case, it's easily seen as 3. First term is 2. So, let's plug in the formula for the 17th term. But first, the formula for the nth term. Now we plug in 17, so we know T1 is 2. We have our n of 17 and our d of 3, and it's just a matter of simplifying it. 2 times 2 plus 16 times 3 or 48, so the 17th term is 50. So if you're finding a specified term, use the formula for the nth term and just plug in that number for n and simplify. Number 4, find the specified term of the arithmetic sequence. There are two ways to do this. I'm going to show you the long way using example 4 and the quick and dirty way in example 5. T2 is 13, T6 is 25, find T20. Now, you will remember that our formula for the nth term requires we know the first term. Well, how do we do that? Let's first figure out what D is. Well, we don't know, so let's use our general equation to find T1 and D. We know that if this is T2, T2 is T1 plus n minus 1, which is 2 minus 1 times D, or 13 in this case equals T1 plus D. Now we use the 25 for the sixth term, and we use the same general equation. Plug in 25 for T6, and you plug in 6 for n, and your formula here is 25 equals T1 plus 5D. So you have two equations, two unknowns. Take a look at the first equation, solve for T1. T1 is 13 minus D. All I did was subtract D from both sides. Now we plug that value of T1 into the second equation, so you get 25 equals 13 minus D plus 5D. 13 minus D plus 5D is 13 plus 4D. Subtract 13 from both sides and divide both sides by 4, and you see that the common difference is 3. So that's the longer way to do it. Use both equations using these values for the term, plug them into the general equation, solve for T1 or D first. Now you know what D is, you can solve for T1. T1 is 10. So to find T20, you just plug it into the general formula. T20 is T1 plus 20 minus 1 times D. T1 is 10, D is 3, and you just combine the terms, and you get this 20th term is 67. So that is the first way to figure out this problem. Find T1 and D using two general forms of the equation and then solving for one of the variables first. Now we have T2 equals 9 and T5 equals 21. We want to know T41. Here is the quick and dirty way. How many differences are there between T2 and T5? Well, there are 3 of them because it's 5 minus 2. So the total between T2 and T5 is the equivalent of 3D. 3D is going to be the difference between T2 and T5, or 12. So our equation is simply 3D equals 12. Divide both sides by 3, and D is 4. Now what you can do is solve for T1 by plugging them into the general equation. T2 equals T1 plus 4. T2 is 9, T1 is 5, because 5 plus 4 is 9. Now that you have D and T1, you can use the general equation to solve for T41. There's your general equation. Substitute 41 for n, plug in all the values, and simplify. And you see that the 41st term of this arithmetic sequence is 165. So, in this example, you just figure out how many differences are there between 2 and 5. In this case, there are 3. It's basically the difference in term numbers. You find the difference between the values of each term and divide them into each other. In this case, it's 12 divided by 3 to get your difference of 4. Next, the arithmetic mean. This is what you might have called before the average. A single arithmetic mean between two numbers is called the arithmetic mean of the numbers. The arithmetic mean of A and B is called the average and can be calculated by A plus B over 2. I don't think I need to say much more than that because you should know what the average is by now. Example 6. Find the arithmetic mean or average of negative 7.8 and 3.6. I'm going to presume you all can do this, because this is something you should have learned back in 5th or 6th grade. Take the average of the two numbers, divide it by 2, and your average is negative 2.1. So, when the question asks for only one arithmetic mean, you merely add the two numbers together and divide by 2. But you know it can't be this easy, because this is Algebra 2 Trig. Find the arithmetic mean of 1/2 and 1/3. Well, it is this easy for this one. Again, do the same thing. Add them together, divide by 2. Make sure when you add fractions, you change them into the least common denominator. So 1/2 is 3/6, 1/3 is 2/6, Combine their 5 6. 5 6 divided by 2 is 5/12. Let's continue. The terms between two given terms of an arithmetic sequence are called arithmetic means of the given terms. For example, given the numbers 10 and 22, 13, 16, and 19 are three arithmetic means between 10 and 22. You notice that with those three, the difference between each of those five numbers are all equal. Given 10 and 22, 10, 14, 18, 22 are two arithmetic means between 10 and 22. Again, notice the difference between all four numbers this time are equal. And lastly, the single arithmetic mean is merely the average between 10 and 22. Again, the same difference between the first, the middle, and the last numbers. Now, the way you calculate this is using the arithmetic sequence. That will help you calculate arithmetic means. Think about how many terms go in between. That will help you calculate the mean. Insert three arithmetic means between 18 and 54. So if you were to draw it out like this, you would have three blanks. Let's call 18 the equivalent of T1 and 54 the equivalent of T5. The question is, how many differences are in between? There are four. 1, 2, 3, 4 between T5 and T1. The total difference is 36. So just like we did in example 5, take the number of differences and divide that into the difference between the two numbers. So 4D is 36, D is 9. Now you can figure out what the various terms that go in there are by plugging in for T2, T3, and T4. So add D to the previous term. 27, 36, 45, and 54. So this is three arithmetic means. If they ask for two, you would have three differences for a total of 36, and your D would be 12. If we're two arithmetic means, we just did that. If it's one arithmetic mean, you just take the average. Alright, so how do we find the formula for the nth term of an arithmetic sequence? You can calculate the first term T1 and the common difference D. You can use this formula. Tn equals T1 plus n minus 1 times D. How do we find specific terms of an arithmetic sequence? Find the formula above and plug in the appropriate value for n. I don't think arithmetic sequences are that difficult to understand, that difficult to grasp. You just have to memorize this formula and remember how to calculate the arithmetic means. That's it for section 11.2. I can't imagine you have that many questions, but if you do, feel free to ask me online, in class, or on the Facebook page.